Now we discuss about modular arithmetic. So first, to know the modular arithmetic, we have to define some more terms. So first we define divisibility. Let a and b be the two integers, a not equals to 0, we say that a divides b. If there exists an integer k such that b is equals to a into k. Here, if a divides b, we denote as a divides b. So, this symbol denotes the divisibility. If a does not divides b, we write it as a does not divides b. To look after some example, take 13 and 39. Here, 13 divides 39. It is also known as 39 is divided by 13. So 39 is equals to 13 into 3. Here 3 is a integer. Consider it as a k, 13 is a. If we multiply 13 and 3, it leads to 39. Here 39 is a b. So b is equals to a into k. In same way, 7 and 24 is a two integers, say a and b. But 7 does not divide 24. In other words, 24 is not divided by 7. If we multiply any integer with 7, it is not equals to 24. So it is the divisibility. Next we define what is division algorithm. Let a and b be the two integers, a not equals to 0. It is the common statement for all the definition. There exist integer q and r such that b is equals to aq plus r, where the value of r lies between 0 and modulus of a, where modulus of a is a positive number. So r is always lies between 0 and positive integer a, where q is a quotient and r is a remainder. So a divides b is nothing but b is divided by a. So b is divided by a. So here b is equals to aq plus r. So b, a, q, r all are integers. So here a divides the b. So we obtain the quotient and the remainder. So we know that the formula, the dividend is equals to divisor into quotient plus remainder. Here take a b. So let us consider b is a big number. Then a is comparatively b, so a is a smaller number. If a divides b with some term or some integer q, so we written as a into q. Then according to division, b minus aq leads to remainder. So remainder is equals to b minus aq. If you uh, take aq to the LHS, we consider b is equals to aq plus r. Therefore, by this rule, we apply b is equals to aq plus r. So this is the division algorithm. Let a and b be the two integers, a not equals to 0. Next we define what is greatest common divisor. Greatest common divisor, commonly called GCD. Let a and b be the two integers and integer d is greater than 0. Here d denotes the GCD. So let a and b be the two integers and integer d is greater than 0 is said to be the GCD of a and b. So it satisfies the two conditions, that is d divides a. GCD divides an integer a and d divides b. GCD is divides an another integer b. That is d is a common divisor for both a and b. Another condition is h divides a and h divides b. So h is also divides d. That is any common divisor of a and b is also the divisor of d. Therefore, we conclude that GCD of a and b is written as a comma b, or d is equals to a comma b. Here a and b are the two integers, d is denotes a GCD. Next we define what is relatively prime number. Two numbers a and b are said to be relatively prime numbers, are also called coprime if and only if a comma b is equals to 1. Here a comma b is nothing but GCD of a comma b is equals to 1. That is GCD of a and b is 1. Then we say that it is relatively prime number. Take an example 8 and 15. If GCD of 8 and 15 is equals to 1, then we say that 8 and 15 are relatively prime number. Then what is Euclid's lemma? So it is the condition of Euclid's lemma. If A divides BC with GCD A comma B is equals to 1, then A must divide C. So here say that GCD of A comma B must and should be a relatively prime number. So then we say that A divides C. Next, describe Euclidean algorithm, a method of finding GCD of two numbers. Say that two integers or two numbers are A and B by dividing the larger by the smaller, then smaller by remainder, first remainder by second remainder, and so on until exact division is obtained. The last non-zero remainder will be the GCD. Hence, GCD is exact divisor if G or D. So we considered both, whatever it may be, but here G denotes the GCD of A comma B. Then by using a division algorithm successively, we can find integers x and y such that G is equals to Ax plus By.